Memorize means you know them without thinking about them. For example, what's 7 times 6? 42. Let's try that again. What's 8 times 6? 48. Okay, so if that comes to you immediately, you have your times tables memorized. If it doesn't, you don't even have those memorized, which concerns me. So it's somewhere along the line you never forced yourself to memorize them, which is unfortunate. But when you, Kirsten, tell me that 6 times 8 is 48, you're not thinking about 6 groups of 8 and adding those all together, right? You're not thinking that 6 times 5 is 30 and then let me count by 6's up until I get to the 8th term, right? You just know it. That's memorized, okay? These need to be memorized. I will, however, show you a quick little pattern. Let me first fill it in. This is 0. This is 1/2. This is root 2 over 2. This is root 3 over 2. And this is 1. So let me tell you how those sine numbers work as you're working from the smaller angles up. This is technically, pay attention to this, it'll help you memorize it. This is root 0 over 2, simplified. Root 1 over 2, once you simplify it. Root 2 over 2, doesn't simplify, is what it is. Root 3 over 2, doesn't simplify. Root 4 over 2, simplifies down to 1. Think about that. Root 4 over 2. Isn't root 4 just 2? And 2 over 2 is 1. Same thing with root 0 divided by 2. Root 0 is just 0. 0 divided by 2 is just 0. Same thing with root 1 divided by 2. What's the square root of 1? 1 divided by 2. So those special angles end up being those nice values that actually have that pattern. Root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2. But like these three, obviously reduced. Okay? The beauty of, well, let me ask you this. Do you remember this from, I'm going to say probably not, but I'm going to ask because I know you do it in geometry. Do you know the sine of 50 equals the cosine of what? Remember that property? Nope. The sine of 50 does not equal the cosine of 50. Otherwise, we wouldn't need two separate columns if they were always the same. You remember? The sine of 89 equals the cosine of what? No, not a 1. It's a geometry thing. The sine of 50 equals the cosine of 40. The sine of 89 equals the cosine of 1. Let me fill that in. Do you see the pattern? Let's try another one. The sine of 70 equals the cosine of, does anyone think they know now? You don't see the connection? Kirsten? 20. Excellent. After more examples, you'll pick up on it. How about the sine of 82 equals the cosine of, Nathan? 8. Raise your hand if you think you now see it. Micah? Sine of 85, Micah, equals the cosine of what? 5. Raise your hand if you think you now see it. Isaiah? They have to add to 90. Okay? Which is why the sine of 45 equals the cosine of 45, for the record. They're the same value. But the sine of 0 is going to equal the cosine of 90. So the sine of 0, which is 0, is the same as the cosine of 90, which is 0. This column is going to go backwards. This will be 1/2. That way the sine of 30 equals the cosine of 60. 30 and 60 add up to 90. The cosine of 30 is going to equal whatever the sine of 60 was, root 3 over 2. And the cosine of 0 is going to equal the sine of 90, which is 1. Now that they point that out, do you remember doing that last year? Some of you shaking your head no doesn't surprise me. Some of you shaking your head no surprises me. Tangent. Tangent is what divided by what? Do you remember this? I don't know if you did this last year. We'll learn this more this year. We'll talk more about why. Tangent is the same as the sine divided by the cosine. So again, I want you to memorize these, but at the same time, I also want to show you how if God forbid you forget in a pinch, you can kind of construct it. So if I just take 0 divided by 1, that's going to give me the tan of 0. 1/2 divided by root 3 over 2. If you did that fraction divided by fraction, if you keep, change, flip, and then you'll have to rationalize, you will get root 3 over 3. That one's harder to see, but that is what 1/2 divided by root 3 over 2 is. What's root 2 over 2 divided by root 2 over 2? 1. Anything divided by itself is 1. And then obviously we did this one yesterday. That is root 3 over 2 divided by 1/2 would give you that. And then what's 1 divided by 0? No, it's not. Undefined. The tangent of 90 is going to give you an error. The tangent of pi over 2 on your calculator is going to give you an error. Okay? Now, the mode of your calculator is critically important. In geometry, you always had it in degrees. In Algebra 2, you're almost always going to want it in radians. So on your calculators, under your mode, this is in degrees, which means I was probably working with someone in geometry. Put it in radians. Second, quit. So now, if I go to find the tangent, well, let me do one that'll work out nicely. The cosine, I'm in radians, so I'll do pi over 3. The cosine, you have that button, of pi over 3 is going to give you 0.5. Does everyone see that? Obviously, that's what the table tells us as well. If I type in the cosine of 60 right now, I will not get 1/2 because I'm in the wrong mode. If I type in the cosine of 60 and I think I'm looking for the cosine of 60 degrees, I'm going to get it wrong because the cosine of 60 degrees should be 1/2. That's because my calculator right now is in radians. If I go back to the mode because I know I'm looking for the cosine of some certain degrees, and then I hit cosine of 60, now I will get 1/2 because I just put it in degrees. Here when I calculated it, it was in radians, so that's not what I was after. So make sure you are on top of the mode. Does this make sense? All right, let's go to our notes. So anything 0 through 90, these critical angles, you're not going to get a calculator for a lot of what we're going to do here, okay? 0 through 90, for right now, because you don't have them memorized yet, have this chart next to you, okay? You're going to have to memorize those. Based on the fact that you'll have these memorized, you will then be able to expand your knowledge and be able to answer these kinds of questions. Now, first faux pas on my part, these should all have degree symbols so that we are very clear that those are not radians we're talking about. And we are not going to use our calculator. You will not have your calculator. I will take that away from you. Just so you can get these concepts down. So when on the Regents, they write the question so that you won't be able to use that a calculator is not going to help you. You'll still have the thought processes to be able to answer it. Okay? So, sine of 240. Couple things. First question is, what quadrant is this in? 240. What quadrant? 3, correct. So here's 180. Here's 270. So initial ray, terminal ray of 240. So let's just start there. All students take calculus. I'm looking for the sine of this angle. I'm in this quadrant. Is the sine positive or negative in this quadrant? negative. So I know that my answer is negative because that's a third quadrant angle. So start there. Now for the value. The value that we negative what is going to come from the reference angle. What is the reference angle of 240? Reference equals 60. So whatever the sine of 60 is, that's the number we're going to take. So from your chart, the sine of 60 is root 3 over 2. So your answer for the sine of 240 degrees is negative root 3 over 2. Now, this says to find the exact value, so guess what? Your calculator wouldn't be helpful. Because when you do this on your calculator, what mode should I be in? Okay? And when I type in the sine of 240, your calculator is not going to give you the exact value. Your calculator is going to give you a decimal. So you wouldn't be able to get the exact value if that was an open response. How are you going to turn that into it? It's not like you can use your fraction key, because your fraction is not going to give you a radical. So negative root 3 over 2, I can then show you that that's the right decimal. But your calculator wouldn't give you that exact value. Your calculator is going to give you a decimal. Okay? Does that make sense? Cosine of 330. So let's put steps here. So what quadrant, which is going to allow you to decide positive or negative, followed by reference angle, which is going to allow you to find the value. Because everything we do will have a reference angle of either 0, 30, 45, 60, or 90. You would never have to do this if that wasn't your reference angle. If your reference angle doesn't boil down to one of these, you won't have to do it. Okie doke? So, 330, what quadrant? 4. So there's 0. We open all the way up to 4. That's 330 to 360. So, positive or negative? Take a minute to think about that yourself. Is this cosine of 330 going to be positive or negative? Who thinks they know? Nate. Positive. Because you're taking the cosine and you're in the fourth quadrant where cosine is positive. Plus. Obviously, you don't need to write the positive sign, but I think just to document that we thought about it, I think it's worth writing. And then what's our reference angle? John. 30. And so to get our value, we're doing cosine, so we go to our chart. The cosine of 30 is root 3 over 2. Good? Try option C on your own. Should take about a minute. Kaylee Smith, what'd you get? Raise your hand if you got negative 1. Raise your hand if you got something different. Raise your hand if you're lost and you want me to help you. Raise your hand if you're lost. Okay, so Cameron, where do you fall? Because you haven't raised your hand yet. Did you get negative 1?
Yeah.
Oh. Raise your hand if you got negative 1. Jake Hutch, where do you fall then? Did you get negative 1? Let's try this again. Raise your hand if you got negative 1. My Michael, what category do you fall into? Oh, but you're not lost. Okay. So did you stop trying to finish it once Kaylee said -1? Why? Yeah, but don't you want to see whether or not you could get that on your own? No? Then I won't waste my time. Okay, so those are all degrees. Let's jump to radians. Same process. What quadrant? What quadrant's 5 pi over 6 in? The second, because here's 6 pi over 6. And we've opened this to 5 pi over 6. So positive or negative? Let me go with Andy. Is the answer going to be positive or negative now that we know that 5 pi over 6 is in the second quadrant? Positive, because we're taking the sine, and all students take calculus. So sine is positive in the second quadrant, so we're taking a sine, so it's positive. Reference angle. What's the reference angle, Aiden? Pi over 6. So to get our value, jump to your chart. The sine of pi over 6, 1/2. So your answer, 1/2. Just to prove it to yourself on your calculator, what mode should I be in? Radians. So switch back. The sine of 5 pi over 6, 1/2. This decimal you could change to a fraction pretty easily because there's no radical involved. Good? Try E on your own. Cameron, what are we thinking? Not sure yet? Do you know if it's positive or negative? Correct, because we're in the third quadrant. All students take, we're down here, and only tangent's positive there, so we're taking the cosine, so that's got to be negative. And then what's the reference angle? Do you know that, Cameron? Okay, so look at your chart. What's the cosine of pi over 4? Why you didn't write it down. The cosine of pi over 4 is root 2 over 2. What's not there? Did you not write those in yesterday?
Oh, I didn't see the...
Radians?
I know, I wasn't looking at the side.
Oh, okay. Cosine of pi over 4, root 2 over 2. Negative root 2 over 2. Raise your hand if you got that. Good stuff. Okay. Flip to the back. Terminal ray of an angle, alpha, drawn in standard position, falls in the second quadrant. Read no further. Draw it. Second quadrant, the angle, which we always kind of label the reference, is alpha. The sine of alpha is 3/5. This is what we did yesterday. Sine is what over what in SOHCAHTOA? Drop your triangle. Sine is what over what? Opposite. 3 is your opposite, so that's here. Hypotenuse is 5. That's there. Pythagorean theorem will give us this. How do we label this? I'm only not doing the Pythagorean theorem because this is one of those special Pythagorean theorems that comes up all the time. Okay, so should I label this 4? Negative 4. Why? I went left. Negative 4. What's the value of tan? Tan is what over what? Opposite is 3 over adjacent is negative 4. Now you would probably, the negative in the denominator, you'd probably see it as negative 3/4, or you might even see it as negative 3/4. Those are all the same thing. Those all are negative 0.75. Okay? Okay, understanding that when there's one negative involved, it can go with the denominator, it can go with the numerator, or it can go with the entire fraction and just be out in front. Okay? Next example, an angle theta has a terminal ray that falls in the fourth quadrant. Read no further. Draw it. Terminal ray, fourth quadrant. Drop your triangle. Always to the x-axis. Label your theta. So the cosine is 1 over 3. Grace, cosine is what over what? Grace. Adjacent. So which one's the adjacent, Grace? Correct. 1 over hypotenuse. That one we are fine. We know how to pick out the hypotenuse. And then Pythagorean theorem here. We might actually have to do 1 squared plus x squared equals 3 squared. This is just 1, right? So I'm going to subtract 1 from both sides. So x squared equals 9 minus 1 is 8. Square root both sides. I get x equals plus or minus root 8. Which is it? Plus or minus? Minus, because I'm going down, right? What are you going to tell me, Nate? And you want to simplify root 8 like we picked up on our homework last night? Root 8 is root 4 root 2, right? The square root of 4 I like because that's just the whole number 2. So negative 2 root 2. So now we can actually read the question. Determine the value of sine. Sine is what over what? Okay, so opposite is negative 2 root 2 over hypotenuse is 3. And look what naturally happens. Is my sine value positive or negative? Negative. Isn't that what it's supposed to be based on all students take calculus because only cosine is positive there? So by default, sine should have been negative, and it was because we processed that negative leg when we did the plus or minus. That makes sense? All right. And then last thing, just to reiterate, I presented this yesterday, but in a different way. But since the sine is the opposite over the hypotenuse, isn't the numerator always smaller than the hypotenuse? So a smaller number over a bigger number is always less than or equal to 1 or greater than or equal to negative 1. So any time you take the sign of a value, you're going to get a decimal, essentially. Might be a negative, might be a positive, but it's going to be something not greater than 1. Same thing with cosine. And do you remember what we said about tangent? Can be anything. To be honest with you, let me go back to your chart. All of these values, if you type those in, are between negative 1 and 1. So are this cosine. But this root 3 is actually greater than 1, and it can be because it's in the tangent column. Did I screw it up? Whoops. Cosine should have been adjacent. Thank you. I didn't even realize that. Opposite over adjacent. I didn't even look at those. I must have, you know what, I bet I probably copied and pasted and then, whoops.